diagram above shows the sector AOB of a circle with center O and radius 6.5 centimeters and angle AOB equals 0.8 radians. A, calculate in centimeters the area of the sector AOB, and B, show the length of the chord AB is 5.06 centimeters to three significant figures, and the segment R, it's a segment here, shaded in the diagram above, is enclosed by the arc AB and the straight line AB. As the arc AB and the straight line AB. Calculate in centimeter the perimeter of R. So we want the perimeter, we want the arc AB plus the straight line AB. We need to calculate in centimeter the area of the sector AOB. So to calculate the sector AOB, we basically write area of sector equals a half r squared theta and a half times 6.5 squared times 0.8 radians. When we multiply those together, we get 16.9 centimeters squared. So that will be the area of sector. And that's what we're looking for. Show that the length of the chord AB is 5.06 centimeters to three significant figures. We want to find that length AB. We know the angle. We know one side. We want to find the other length. If we split this line up we bisect that line, and that's right angle, that's right angle. That side is going to be 0.4 radians. And this side is going to be X. And that side is X. Again, that side is also 0.4. We know that side here. So we could use Socatoire. With Socatoire, we've got what we have. We have the angle and we have the hypotenuse. We're looking for the opposite. So we need something to do with opposite and hypotenuse. Opposite hypotenuse is sine, so we'll be using sine. Sine of 0.4, that has to be in radians, should be equal to opposite x over the hypotenuse 6.5. Therefore, if I multiply both sides by 6.5, x equals 6.5 times sine 0.4 in radians. Okay, so we have to make sure the calculator is in radians. To be in radians, you need to turn on your calculator and then press Shift menu. You'll see angle unit, press 2. Then you see radians, press 2 again. And now you see from the top of your screen, you will see R. R means radians. That means it's ready for calculation in radians. So punch in 6.5 times sine 0.4, close bracket, and you get 2.531. And we need to times that by, that's x, but we want 2x. So it's 2.531 times 2, that would be 5.06. So therefore, AB equals 2x, which equals 5.06 centimeters. And that's the distance we're looking for. Calculate in centimeter the perimeter of R. So the shaded part is R. We know the length AB, and the other length we need to find is the arc AB. For the length AB, we got 5.06. Now to calculate the arc, the angle of arc, the arc L is, let's call the L, R theta. If you don't know how to get that information, all you need to do is compare the circle, which is 2 pi r length, over the angle of the circle, which is 360 degrees, and compare to arc length L over the angle of arc, which is theta. We know that 2 pi equals 360 degrees, so therefore 2 pi and 360 cancel out, and we got r equals L over theta. And to find L, multiply both sides by theta, you get r equals r times theta equals L. R is 6.5, so L would be 6.5, which is the radius, times the angle, and the angle of the sector in this case is 0.8. And so if you times 6.5 times 0.8, we get 5.2. Now the perimeter of R will be equal to 5.2 plus 5.06, and that will be 10.26. And we want in 3 significant figures. We could write in 3 significant figures, so that would be 10.3 centimeters. And that's the distance we're looking for.